8.2, solving equations. We've got a couple of different formats of equations here. We've got a times x plus b equals c, and x over a plus b equals c. So we've got two terms on one side of the equation this time. So it complicates it a little bit. So let's have a look. Link the ideas. Working example number 1, solving two-step equations with fractions. So these are called two-step equations. So we've got an example here, and we're being asked to solve and check. 2 times x plus 1/10 equals 3/5. So, like before, we're needing to isolate our variable to find out what it is equal to. So in order to do that, we have to get rid of all the other stuff that's on that side of the equal sign along with it. And so we're going to use reverse operations again. And in fact, we're going to use the reverse order of operations. So instead of starting with brackets, we will end with brackets using the reverse order of operations. So first up here, we've got 2x plus 1/10. We're going to have to get rid of this 1/10 by subtracting it from both sides. That's step 1. So 2x plus 1/10, then we're going to subtract 1/10. And if we do it on the left side of an equation, we have to do it on the right side as well to keep it equal. So then 1/10 minus 1/10, well, that equals 0. So that can then vanish, leaving you with 2x on the left-hand side. On the right-hand side, though, we've got 3/5 minus 1/10. Well, in order to do that calculation, we need to have a common denominator. And in this case, we've got a 5 and a 10. So we're going to work with a common denominator of 10. Which means we need to double the 5 to get to 10. So if we multiply the bottom by 2, then we multiply the top by 2. So 3 times 2 is 6, and then 5 times 2 is 10. So now the right-hand side becomes 6/10 minus 1/10. And that is pretty straightforward. 6 minus 1 is 5. And then the common denominator, we don't do subtraction with that. It just stays a 10 on the bottom. So now we have a new equation that's 2x is equal to 5/10. That's what we're working with now. So now, you can convert this to lowest terms now if you want. Results in easier numbers to work with in the end, but you could just reduce all your fractions at the end as well. In this case, 5 over 10, both are divisible by 5. So 5 divided by 5 gives you 1, and 10 divided by 5 gives you 2. So 2x equals 1/2. So now we're faced with the same type of question that we dealt with in the previous section. We've got a single term on both sides of the equal sign. And in this case, we've got a coefficient of 2. This is 2 times x. The opposite of times is divide. So we're going to divide both sides by 2. Divide the left side by 2, divide the right side by 2. 2x divided by 2 leaves you with an x. 1/2 divided by 2, well, that's the same as saying 1/2 divided by 2 over 1, which then you can take the reciprocal of 2 over 1, it becomes 1/2, and you can convert your division into multiplication. So then you're left with x equals 1/2 times 1/2. Well, 1 times 1 is 1, 2 times 2 is 4. So x equals 1/4. And so that's the solution. Let's turn the page. Now there should be a verification process involved as well. We need to check that x is equal to 1/4 is the actual solution to this. So we substitute it back in, and you can solve it that way, or we can even model this on a number line. So we can find a common multiple of 5 and 10, and in this case it's 10. So we'll divide our number line between 0 and 1 into tenths. That's what this number line shows. So if we have 3/5 on the right hand side, so we're going to find 3/5, and that is right here. It's going to be 1, 2, 3, 4, 5, 6 tenths is the same as 3/5 if you're using equivalent fractions. So this is where 3/5 ends, right here. That means that 2x plus 1/10 is equal to 3x, or 3/5. 1/10 is just one space, so we can back it up here. And then that means this leftover bit is 2x. So that's 1, 2, 3, 4, 5 tenths is equal to 2x. Now, half of 5/10 is going to be 2.5/10, so that's a little bit tricky. So we're going to have to actually take this down to another level with our denominator and break it into 20ths in order to be able to find half of this point. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is now 10/20ths. You can divide that by 2 to give you 5/20ths, which is what we've got here. And then in lowest terms, that's 1/4. So it's a little weird. Once you see the end result, it's easier to see the process. 2x plus 1/10 is the same as 3/5. So you draw your 3/5. You can subtract that 1/10. That little bit there that's left over is equal to 2x. So you split it in half to figure out what x is. And yeah, it is in fact 1/4. So that's another way to actually calculate the solution even. But we've come up with the same answer, so we know that 1/4 is correct. Another example here. K over 3 minus 1/2 is equal to negative 1 3/4. So K over 3 minus 1/2, that's our left side. I'm going to convert this into an improper fraction for the right hand side. 4 times 1 is 4. 4 plus 3 is 7. So this becomes 7 over 4. And don't forget about your negative. So this has to stay negative here. So it's negative 7/4 on the right hand side. So we've got that. Now we've got a bunch of denominators here. Eventually we're going to need a common denominator for all of these to work with. So we're going to find the lowest common multiple of 3, 2, and 4. And if you write out your multiples of 2, 3, and 4, you'll find that 12 is a common multiple for each of those. So we're going to use 12 as our common denominator here. Now in order to do that, this is an interesting process. We can actually multiply everything, each of these terms, by 12. And by doing so, rather than having denominators, we're actually going to get rid of our denominators completely. It's kind of a neat thing. So if you multiply K over 3 by 12, then 12 divided by 3 is equal to 4. So that's going to actually leave us with 4 times K. If you multiply 1/2 by 12, that's going to give you 12 over 2, or 6. So that's what's going to show up here. And over here, if you multiply negative 7 over 4 by 12, that's going to be, let's see here, 84 divided by 4, which is 21. So it's going to be negative 21. So by finding those common multiples and then finding that number, we can use that number, multiply it across each term, and all of a sudden the denominators vanish and we're not dealing with fractions anymore. So we end up with 4k minus 6 is equal to negative 21. That simplifies it a little bit for you. So then, now we're faced with a somewhat simpler two-step equation to deal with. So we need to eliminate this subtraction of 6, and we do that by adding 6 to both sides. So negative 6 plus 6 becomes 0, so this leaves it with just 4k on the left. Negative 21 plus 6 leaves you with negative 15. Now we're down to a one step, 4 times k, so the opposite of multiplying by 4 is going to be to divide by 4. So we're going to divide left by 4, and in this case it's negative 15, and we're going to divide that by 4 as well. 4 divided by 4 is 1, so that's 1k, or just k. 15 over 4 is an improper fraction, but we can leave it at that for the moment. So k is equal to negative 15 over 4. That is negative, 4 goes into 15 3 times. That gives you 12, so there's 3 left over. So negative 3 and 3/4 is your solution there. You will practice this process a fair bit, so it will start to get easier on how to eliminate the denominators and fractions. All right, now, of course, we've got to check our work. So left side of the equation, right side of the equation. Everywhere that there's a k, we're going to substitute in our improper fraction, negative 15 over 4. We're going to do it as an improper fraction. Our answer is a mixed number, and that's great. But when we're working with it for checking purposes, a mixed number doesn't work real well for us. So we can just step one step back and use the improper fraction. So negative 15 over 4, that's what this k is, over 3, which is the same as divided by 3. These mean the same thing. And then subtract 1/2. So according to BEDMAS, we then need to do our division first when we're doing the check. So instead of dividing by 3, we're going to multiply by 1/3. That's the reciprocal of 3 over 1 is 1 over 3. Change your division to multiply. So we do that first. 15 times 1 is 15, 4 times 3 is 12, and then of course we've got this negative here. So then that reduces it down to negative 15 over 12 minus 1/2. Well, that's subtraction, so we need a common denominator. We're looking at 2 and 12. We're going to use 12 as our common denominator. Oh, no, sorry. I guess we're going to reduce this one first. 15 and 12 are both divisible by 3. So 15 divided by 3 gives you 5. 12 divided by 3 gives you 4. So that reduces this down to negative 5/4 minus 1/2. You could do the subtraction first and then reduce. But in this case, we're going to do the reduce it first. And we'll use a common denominator of 4. So then this, instead of 1/2, multiply that by 2, multiply that by 2. So now we have negative 5 over 4 minus 2 over 4. When you do that math, the 4 stays in the bottom. Negative 5 minus 2, that's the same as adding the opposite. So you can add a negative 2 instead of subtracting a positive 2. It means the same thing, and you'll end up with a negative 7 over 4. Which is 4 goes into 7 once with 3 remainder. So it's negative 1 3/4, which is exactly what we had on the right hand side, so we know we've got the right answer. Negative 1 3/4 was on the right. That's what we've calculated on the left. So in that point, we know that our solution, that k is equal to negative 15 over 4, is correct. All right, so now it's a show you know. Give it a go.